Welcome to doassignment-ca. Here is the problem. A particle starts from s equals 0 and travels along a straight line with a velocity v equals t squared minus 4t plus 3, measured in meters per second, where t is in seconds. Construct the vt and at graphs for the time interval 0 less than or equal to t, less than or equal to 4 seconds. Now let us work through the solution step by step. We start with the given velocity function. V of t equals t squared minus 4t plus 3, measured in meters per second. Since this is an upward opening parabola in time, we need to find its zeros, its minimum, and its values at the endpoints of the interval. Setting v equal to 0 and factoring gives t minus 1 times t minus 3 equals 0, so the velocity is 0 at t equals 1 second and t equals 3 seconds. Between those two times, the velocity is negative, meaning the particle reverses direction. The vertex of the parabola is at t equals 2 seconds, found using the formula negative b over 2a. Plugging t equals 2 into the velocity function gives v equals 4 minus 8 plus 3, which equals negative 1 meter per second. This is the minimum velocity on the interval. At t equals 0, the velocity is 3 meters per second. At t equals 4 seconds, it is also 3 meters per second. Summarizing all key points, the velocity starts at 3, drops to 0 at t equals 1, reaches a minimum of negative 1 at t equals 2, returns to 0 at t equals 3, and rises back to 3 at t equals 4. Connect all 5 points with a smooth parabola. The curve lies above the time axis from t equals 0 to t equals 1, dips below the axis between t equals 1 and t equals 3, touches the minimum of negative 1 at t equals 2, then rises back above the axis from t equals 3 to t equals 4. To find acceleration, we differentiate the velocity function with respect to time. The derivative of t squared minus 4t plus 3 is 2t minus 4 in meters per second squared. This is a linear function, so the at graph will be a straight line. At t equals 0, the acceleration is negative 4 meters per second squared. At t equals 2 seconds, it is 0. At t equals 4 seconds, it is positive 4 meters per second squared. The zero of acceleration coincides with the minimum of the velocity curve, which makes physical sense. Draw a straight line starting at the point 0, negative 4, passing through 2, 0, and ending at 4, positive 4. The slope of this line is 2 meters per second cubed, which is constant, consistent with v being a quadratic. The line crosses the time axis exactly at t equals 2 seconds. To summarize, the velocity function is a parabola opening upward with zeros at 1 and 3 seconds, a minimum of negative 1 meter per second at t equals 2 seconds, and endpoint values of 3 meters per second. The acceleration function is a straight line running from negative 4 meters per second squared at t equals 0, crossing 0 at t equals 2 seconds, and reaching positive 4 meters per second squared at t equals 4 seconds. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.